Okay, let me see. Today we will be solving mesh. This is the last problem we will be solving in Reeborg's world. Uh, so it's like they have given instructions. So in the mesh, it is Reeborg is trying to go to the uh, goal post or the goal. So here it is a link where we can access that. So they are saying to us to use if else statements so that Reeborg can find the exit from the mesh. Unsecret to have Reeborg follow along the right side of the mesh, turning it right if it can, and go straight and it cannot turn right. Or we have to check if it is turned right or we can turn it left, depending on the conditions we will. So the functions what we should know is move, turn left, uh, front is clear is a new function, or wall in front is a new function. Right is clear we have already used, a wall on right is also used, and we are using at goal also we have already used. So let's see how we will be writing it. So I am just removing everything here. So it's like my robot is at this location, and this may vary actually. The location, starting location of the robot may vary. So I know that the right to turn right we have to use this function which we are already using from last multiple times. So at right if it is a wall, then the robot should move front, and then it should turn right and move again. So if my robot is staying here, it is checking where to move. So now what I will do, the first option is like we have to reach the goal, like the flag what we have defined. So while at goal, while not at goal. So until the robot reached the goal, the loop will continue. So what it will do, if so I'm using the functions, if wall on right, oh sorry, thank you. Okay, now it's visible, right? So again now my robot is at this location. I want to go to this goal post. So it is like what we have seen already. So this function what we have defined, define turn right, and then while at not at goal, if all on right. So I'm checking if all on right. So my robot should move and turn right. So just I am preparing this, just running the. Okay. So my robot is at this location now. It is actually going into infinite loop. If it is above 1000, right, it is actually going into infinite loop. So we have to skip this. So for right it is not there. So there is no wall on right. So similarly, but if there is no wall on right, my robot should move right. So, but moving front, we have to check the condition if the front is clear or not. So, else if which condition we can use? Front is clear, then move and resetting again. Code is not intended correctly. Oh, it is not intended correctly. Okay. So it is again goes into the loop. So what we can do is, so I'm writing another condition. So this is a bit complicated. So so here, okay, let me run it again. Ouch. So I will run by step what it is doing. While at not goal, if wall on right, okay, I have to turn this. First I have to turn my robot and then I have to move it. Okay. So here again, if wall on right, turn right. Or actually what we can use instead of right is clear, I think we can use instead of wall on right. If right is clear, okay. So instead of wall is right, if we use right is clear, then we can just turn it right and we can move that right instead of wall. Okay. So, okay, I forgot if not wall isn't right, it's negation. Instead of negation, we can use if right is clear, so that the robot is checking on it right if it is clear or not, and then it goes. So now robot is checking it's not. So just so now it is checking clear or not. Right clear, now moving. So right is not clear, so it is turning left. and then again it goes straight. So it's checking. If right is clear, turning right. And we have achieved this. So, but again, so this is we have achieved easily, but what if the robot has different position? Like I meant to say, we have. Let me open one of the world. So if my robot is at this position and I run the same code, let me check, and then so it is moving right. It is again turning left, turn right, and got. So it goes on to infinite loop. So for our confirmation, what it is, if it is having 1000 plus steps, then it is moving into 1000. I meant to say infinite loop. If it is here the steps is, so we need to reduce the steps. So there are multiple ways to do this. So one of the way what we have think about is, so before going into this while loop, we will write another while loop. If front is clear, move, and then left. So here why, let us see, I think front is clear only, right? Or yeah, I think front is clear only. So why we have written this loop means, so that robot will move a step and it will check whether it has having and it will turn left and it will check whether it is having any uh, hitting or not, like any wall or any clear or not. So if we run again the same, so uh, so if we carefully observe, the robot came at the first position what we have seen, like yeah, now it is. So instead of going into infinite loop, so what we will be doing is, we have written another while loop to say the robot, if front is clear, then you move and turn left. until the front is clear, it will move. If it is something uh, got hit, like if it is not, the front is not clear, then it will turn left. So why we have done this means, uh, because it is going into infinite loop depending on the image whatever we provided. That's why we have done it. So similarly, we have checked one world. So let me open the other world also. So now my robot is at this position. So if I remove this again, just I am removing this. So here this is already what we have written. So while not at goal, so it's what we have like coded already in the previous sessions as well. We are saying to robot, check if it is right is clear, then turn right and move. If front is clear, then move, else just to turn left. So but this condition will go into infinite loop. Because again, if you see this above 1000 means it is going to infinite loop. Above 1000 steps, it should be below 300 400 steps. So again, so the robot is moving in the infinite loop. uh, so now I am closing it, and again, so this is actually one of the way to say the robot don't go into infinite loop. You just go to whether any wall or any obstacle is there. Up to that you just move, and then after that you just move and then turn left. Once you turn left, then it will go into the next loop. So again, so this is one way. So it's again going to this side. So now it got obstacle, then it's going into the goal loop. So this is little bit complicated to understand. Once you have some time, you can just uh, check it, and you can see the how we are doing. So it's again what exactly we are doing. We are actually sending the robot to x1, y1 position, and from that it's again start the journey back. Then, so similarly, we have the third world as well. So it's like depending on the robot position, we have three JSONs. Maybe we will be sharing that. So you can use that to define the robot position at this point, so that it will be easy. So it's like we have to open the world from the file. So we will have three worlds. So if I open this, So now my robot is facing this position, but the position is same. So there are three facings. The robot position will be same, but the facings will be different. What in all these three positions, the robot should go to this post. So maybe this is one of the a simple, I meant to say simple solution, but you can use write multiple solutions. This there are multiple solutions it is having. So I think that's it for Reebok's world. We will done with Reebok's world. Maybe again from tomorrow onwards we will be checking multiple exercises, and once multiple exercises are done, then we will be going to intermediate. Maybe if for basics it will take another 10 days to complete all the basic exercises. Then we will be starting the intermediate Python with the class object models. So just try to solve on our own. But this is entirely a difficult problem only. So anyone pinging? I'm not sure. So now going back to SQL, SQL joins. So basic SQLs we have already seen, like select and how to select. So in SQL there is another important concept what is called SQL joins. Joins are nothing but if there are two tables, then we will be combining both the tables depending on the one uh, column where it is common in both the tables. So it is called primary key for the both the tables where it should be having in both the tables so that we will be joining them. So here it's what exactly joins are. So there are actually four types of joins in SQL, mainly inner join, left join, right join, and full join, or we can call it as outer join. So is it my not sure why. Yeah. So now inner join is nothing but if we want to join our two tables data, and we should get only the common data in that both the tables depending on the condition what we have given, so that it will return only records what are having in common in both the sides, both the tables. So something like inner join to display a list of products along with corresponding categories. So if we take the Amazon, so if you select for, I mean to say if you select any, I mean to say electronics or mobiles, so it will display only mobiles, right? So, but in mobiles there are multiple categories, but the main category is mobiles, so it should display all the mobiles in that. So depending on the selection what we have given, so it will come only the mobiles, the matching categories. So here the outer the table might having I meant to say mobiles, and the second table is also having mobiles but with different models. So depending on both the like primary ID, we will combine both and we display it. So for example, we will go to this one, uh, inner join. So there are two tables. So if you see like teacher table, so ID is the common. So here also ID is the common. So now teacher, we have department name. So here name is also having common. So inner join, what we will be defining if we run this submit SQL, select teacher dot name, department dot name. So here we are referring two tables names, right? Teacher dot name. So in this table, from this table, I want this name column. In the department table, I want name column. From teacher, here teacher is the table name, and we are joining inner, not joining. What exactly we are doing? We are inner joining department. So on which we are joining? We are joining in the department with the department ID. So here the ID is different, but here the department ID is different. If you see, it's 11122, but here ID is different. So we will be joining the primary ID where the it is common, like the values are common. So from teacher on, which column in the teacher table we are uh, joining with department. So like in teacher column, the department value should match with department. I meant to say department table, the ID column. Like in teacher table, department column should value should match with department table ID column. So, this all these are very hard to show you. I am just taken this inner join, left join, right join from SQLjoule.net. But if you learn one by one, it will get a very nice idea. Like yeah, again left join. Just if you go to left join, so here what it will return? It will return all the tables values from the left join, even if contain null values. So for example, if you see here, so here the city is having null value, but in the city there is all the name, country, and everything is there. So what we will be doing? So here from games dot year and city dot country from games. So games is the my table, and we are joining left join city table on which games dot city and city dot name. So here if we join, so 1 2 3 4, but 4 2032 is empty. So now it should generally, if you use the inner join, right, it will return only uh, three values, but if we are using left join, it will return four values. SQL to system from games left join on city dot name. Okay, it's giving some issues. So if we run the left join here, so in the teacher department there is null values also, right? So it will display the null value also. If you see, so but what if we have given only inner join, and then only the corresponding whatever the matching, it will display only the matching. But if you use the left join, so well, the department having value or not, it will display like, so it is displaying the name, but there is we can't get department dot name from this uh, yeah, this table, like the department table, because there is no a common ID. But if we have used an inner join, we are getting the, so similarly right join is like, so in this department ID for engineering, there are no department, like there is no three, right? So for engineering, the department ID is 3, but in the teacher table, there is no department ID with any 3. So that's why now it returns all the records from the right table, like the department table what we are using. So now the similar way, if we give only join, so it's like outer join, it should return everything, like the before whatever the null values are there, it should return that one. Whatever the null values are there in the both tables, it should return everything. Sorry, for joining. Join. Here join is, here it is join is taking as inner join only, but generally uh, the outer join or full join. Full join where it is one column teacher name and field list teacher dot name full outer join. Okay, here depending on, okay, they are using MariaDB in SQL Jude.net. Maybe the full outer join won't be there in this. But if we check the SQL, like W3 schools also, so the concept is same. It should return everything, all the null values whatever it's there. It should return something like this, the full outer join. So here we should have to run. I'm not sure they have even. So they have did the same thing like customer dot name orders dot id. What we have teachers dot name and teachers dot id from customers, like customers and orders. But here we have teachers and departments on customers. So order by is like it will order like a sorting. It's called. We can, if we remove this also, this should work. And depending on what are the DB we are using, it might change. Like some don't support outer joins, and some syntax might change. Generally, the similar syntax will be across all the like all the SQLs, maybe MySQL or SQL Server. There will little bit differences, but general the concept will be the same. SQL syntax with the manual corresponding to your MariaDB server. Stop the default. What editor? SQL, there should be SQL. Just I'm checking where we can run the SQL queries. SQL. So there is no joins. Okay, sorry, there is joins. Left join. Because it's like they're saying to select all the. Okay. Okay, sorry. Where there is a match in both the sides. No join. Join class. Okay, I have to give the. I'm just checking for outer join. The records from customer table plus all the matches in the orders table. So, and this is join customers. Sure. Okay, plus orders in the orders table. Orders table. Okay. So I want all the records from customers table select right and then okay match. Okay. So here try it also. It should have. Yeah, here there is no try it also what I am checking. Okay. The concept is similar to what we are discussing, but depending on the statements they give, we have to understand which joint to use. Depending, so it is very careful. We are using the joints. Otherwise, it may result sometimes it may result in deadlock also. We are using all the joints. Any questions regarding this? So just try to solve on your own. Both. So just try just learn about the joints in SQL. Generally, there multiple joins will be there. A self join is also one thing where we do with the same table. We will join with the same table. The any other column we will be joining with the same table again. But that is rarely used. But only we have four major types of joins: inner, left, right, and outer. If no questions, I am stopping.